Today, we will be going over the process for how to set up and solve inequality and equation word problems. For yesterday's class, we went through how to set them up and we looked at the steps for how to do that. We didn't do much solving, but that was review. And the solving today is what we're going to add in. And it should also be review since we've covered it before. However, if you have any questions, do please ask them and let me know. So I'm going to share my screen with you all so we can get started. So when solving applications of any equations and inequalities, once again, these are our steps that we went over yesterday. We're going to use these same steps today to set up and solve these, all right? Our step number one is to read the problem and to make sure we understand all the words involved, okay? Our step number two is going to be to identify what we're being asked to find and assign a variable to represent it. Our step number three is going to be to identify what we are given. Four is going to be to write an equation or inequality that models the situation. And actually, I would put like a little intermediate step between three and four. That's going to be to determine whether it's going to be an inequation or an inequality. And then you're going to write an equation or an inequality based on whichever one it is. Then step five says to solve the inequality or equation. Step five, we didn't do yesterday, and step six, we didn't do yesterday. Today, we are going to do both of those. Step six says to explain your answer in a complete sentence. A complete sentence, all right? So our first example says 5 less than the quotient of 2 and a number is 9. What is the number? We read the problem, quotient. We went through this one yesterday, and we define what each of these things are and how to write this. If you are confused on that, you can go take a look at that video. The only thing for this one that may be slightly confusing is this portion here, this quotient, which just means division. And to set this one up, 5 less than the quotient of 2 and a number is 9. Now here, when we are doing these, since we have started doing inequalities, the inequality is going to go closer to the end of the statement that's giving us the setup. Here is saying 5 less than the quotient. Instead of using that less than sign, this tells us that this is going to be a minus sign. And then that than tells us that this than here is a switch word, not a it's not telling us that it's going to be the less than sign. It's telling us that the order of these is going to be switched. So 5 shows up first in the words, but when we write it out in an equation or an inequality, 5 is going to come second. So when we go to write this one out, this becomes 2 over x. And then since it's 5 less, we're going to subtract. Less means subtraction. Subtract 5. And then is 9. Is tells us it's an equal sign, so it's equal to 9. So 5 less than tells us we're going to switch it. So 5 doesn't come first, it comes second. The quotient division of 2 and a number is 9. All right. That's how we're going to set this one up. And now to solve, we are going to solve like we would anything else by performing our inverse operations. So my first step is going to be to add 5 to both sides. Once I've added 5, I end up with 2 over x equals 9 plus 5 is going to be 14. So 2 over x equals 14. And now my next step, I have these two things being divided. I have this 2 times this x, or 2 divided by this x is equal to this 14. Excuse me. When you see these things like this can be a bit confusing. To make it less confusing, when you see this bit right here, if you have recognized it, you can kind of swap these two, and then that becomes a 2 over 14 is equal to x. Oops. 2 over 14 is equal to x. All right. So these two, when you have your variable on the bottom and you're solving and set equal to another number, you can swap those. But in order to do that, I need to see this little arrow here. Okay. I need to see that you know that that's what's supposed to happen. So you need to draw that arrow in. All right. And so we now have 2, put this down here, 2 over 14 is equal to x. Are we going to leave this like this? We can reduce this one. So let's go ahead and reduce it. 2 over 14 gets reduced to 1 over 7 equals x. All right. If we can reduce our fractions, let's reduce them. And so the main question was, what is the number? And our step number 6 was to explain our answer in a complete sentence. So my complete sentence is the number is 1, or is, let's go like this, 2 over 14, or 1 over 7. All right. And the only reason we have two answers here is because we reduced. I want you all to get familiar with doing that, because that's something you're going to have to be familiar with. If you didn't reduce or that's confusing, that's why we have this 214. So the number is 2/14 or 1 over 7. All right. So now let's look at number 2. Number 2 says, you want to order sunflowers for your friend's birthday. Sunflowers cost $1.25 each, and there is a delivery charge of $3.50. How many sunflowers can you send if you have $16? All right. So my first step, again, if we look above, is to read the problem and make sure we understand all the words. I've read the problem and I understand all the words. I don't think you all would get confused on any of these words. However, if you are confused on any of these words, let one of us know so that way we can help you. Step number 2 says, to identify what we are being asked to find and assign a variable to represent it, we are being asked to find how many sunflowers we can send if we have $16. Sunflowers, we're going to use F for flower for this one. All right, that's going to be our variable. My next step, identify what we are given. We are given that sunflowers cost $1.25 each. And there's a delivery charge of $3.50, and that we have $16. Those are the three things we're given. And now our next step, which is the hard part, is to set it up. So we know what our variable is. Our variable is F, and it represents sunflowers. And we are given the cost of sunflowers. So sunflowers cost $1.25 each per sunflower. So for times F, 125 times F. And then we also have an additional charge of $3.50 for delivery charge. And we want to spend, or we want to know how many sunflowers we can get for $16. Okay. How many sunflowers can we get for $16? And so that's an equals 16. That's an equals 16. So my next step is going to be to begin to solve the problem. I'm going to subtract 350 on both sides, minus 350, minus 350. That goes to 0. And what I'm left with is this 125F equals 1250. Now my next step is, excuse me, to divide both sides by this 125F. To divide both sides by 125. Not F, just 125. 125F divided by 125 leaves me with F on this side, and that's going to be equal to 1250 divided by 125, and that's going to be 10. All right, so now that we've solved this answer, we actually need to go ahead and explain what this means, all right? And that's going to be in a complete sentence. So this means that we can send, or I can send 10 sunflowers because they asked us how many flowers can we send if we have $16, so we can send 10 sunflowers, okay? Now let's look at this last example, and then you're going to move on to your classwork, all right? Number 3 says, you want to order cupcakes for your birthday. Cupcakes cost $3.25 each, and there is a delivery charge of $2.50. What is the maximum number of cupcakes you can buy for $40? All right, so I've just read my problem. That's my step 1. There was nothing I didn't understand in here. If there's something that you don't understand and you're not quite sure how to figure it out, go ahead and ask one of us. My step number 2 is to identify what we are being asked to find and assign a variable to represent it. We are trying to figure out the maximum number of cupcakes. My variable for that is going to be C, okay? C for cupcakes. My step number 3 is to identify what we are given. Once again, what we are given is right in here. The cupcake costs $3.25 each, and there's a delivery charge of $2.50, and then we have $40, a maximum of $40. And now we're going to set it up, all right? This is going to be an inequality because we have this keyword here, and this may be one of the parts that you may get confused about and may not quite understand. This maximum is one of the indicators that we are going to have an inequality. If you think back to that first set of notes we did on inequalities, when we had that word bank for words that indicated what our inequality would be, what inequality sign we would have, what it would be, maximum was one of them. Okay. So now we're going to begin the process of setting this up. We know that these cupcakes cost $3.25 each. So for each cupcake we buy, we're going to get charged $3.25. So that's going to be $3.25 C for cupcakes. And then we also know that there's an additional charge of $2.50. And now we have $40. We can't spend anything over $40. So whatever we spend, whatever this charge is here, this 325C plus 250 has to be less than or equal to our maximum amount of money, which is $40. And now we're going to go ahead and solve it. To solve this, I'm going to begin by subtracting 250 on both sides. Minus 250, minus 250 on both sides. There we go. And what I have left is this 325C is equal to, or not equal to, I'm sorry, is less than or equal to. And you can get that less than or equal to sign if you are in this equation editor portion over here. It looks like the division sign. If you just type in that less than or greater than, depending on which one you want, and then hit equal, it just puts it right under there for you. All right, so now you have that is less than or equal to 40 minus 250 is going to be 3750. And now we are going to divide both sides by 325. My 325C divided by 325 leaves me with just C. It's going to be less than or equal to, and then 3750 divided by 325 is going to give me a decimal. It'll be like 11.538, something along those lines. Yep. And now here's where we have to actually take a second to think about this because we have to explain our answer. It's asking us how many cupcakes can we buy. So we can buy. Now, are we going to try to purchase 0.538 of a cupcake? Does that something that would make sense? No, that wouldn't make sense at all. You can't go to a store and say, hey, I'd like to buy 0.538 of a cupcake or 538 of a cake or 0.53 of a shoe or anything. You have to buy a whole number. So in this case, since we can't spend more than $11, since C has to be less than or equal to $11 and 53 cents or 54 cents if you want to get technical with it, we have to spend less than that. So it has to be $11. C can be $11, but it can't be $12. And these have to be whole numbers because we can't buy 0.53 of a cupcake. All right. So we can buy 11, 11 cupcakes. So be careful when you are explaining these things when you go to the classwork. Think about it for half a second and make sure that it makes sense with what the question is asking. All right. If you have any questions, by all means, go ahead and ask one of us and we will help you. So go ahead and get started on the classwork. It should be the link right underneath these notes. All right.